Buenos dias, I'm Michael Ford. I'm the co-founder of Femto Energy, which is probably one of the newest startups to come out of MIT. I'd like to start by saying it's been wonderful to be here. I came on Sunday. I've been to Chile before, but it's certainly been the most memorable visit I've had to your country. I'd like to especially thank President Ivan and Francisco for a wonderful visit, and most importantly, the visit to Centinela yesterday was incredible. I've seen very large things being done. I've been involved in building nuclear aircraft carriers for the United States, and even that pales in comparison to what I saw yesterday at Centinela. The magnitude and the incredible energy that goes in the workforce was wonderful to see. So thank you for the opportunity. I also like to thank MIT for the opportunity to participate in this program, so thank you for that. Femto Energy is a clean energy solutions company, and as I say, we founded out of MIT recently. You can see our connections here. We were brought together by Professor Jacopo Bongiorno, who's a professor of nuclear science and engineering at MIT. He brought a number of us together in what we call the Advanced Nuclear and Production Experts Group. And that group was designed to do one thing, and it was to look at how we could take advantage of existing nuclear technologies and apply them to low carbon energy. There's a tremendous need for low carbon, and nuclear has been, for many years, one of the largest producers of low carbon energy. Over 50% of the clean energy in the United States, 10% worldwide, and 70% or more than that in France, for example. So the technology is well proven. It's been around for 70 years. Our team is led by the team you see here right now, including Lord Norman Foster, who's our chairman, who is one of the most world-renowned architects. And we have expertise across the spectrum from nuclear technology to energy project development, architecture, and finance. So what are we addressing with our company? Well, it's how to address the ongoing energy transition. And I think, as Yvonne mentioned this morning, we want that transition to occur in a way that transitions us away from fossil fuels and to clean technologies, but we want to do so in a way that makes sure that we still have efficiency, equity, and sustainability. And we want to make sure that the security of the public and the energy sources that they have is maintained in that transition. The challenge, of course, is that the current low carbon energy alternatives are often not as easily adapted to remote location, off-grid, and industrial process. And so we thought we saw an avenue here for us to help companies link up with the developers of low carbon nuclear technologies to help solve some of those solutions. Those transition issues are playing out right here in Chile as I looked in preparation for my trip here. There's anticipated growth in energy demand. There's a need for reliable and sustainable low carbon energy. And despite the fact that this is an incredible country from a clean grid standpoint worldwide, and there's been tremendous growth in clean energy here, there's still land use, transmission, and storage issues that may be challenging for renewables expansion going forward. We think that nuclear batteries could help meet that growth in demand here and worldwide. An example is in copper mining, something I got the opportunity, thank you to Antofagasta Materials and Minerals, for the chance to look at Centinela. I was able to find that there's 14% of the total energy in Chile is dedicated right now to mining, to copper mining. There's an anticipated growth in that, certainly as the need for things like copper grows worldwide, and as the ore degrades perhaps in certain areas, there's going to be the need for additional energy. So water usage may also increase, which takes energy, and there's going to be an electrification of mining operations that I was able to see some of yesterday on my visit. An example could be that the hybrid trucks that are being developed for mining that use electricity and diesel in order to bring the ore out of the mine are being electrified worldwide. There are some mines that are already taking advantage of this, and you can see the kind of energy that they would take, up to 3 megawatts of peak power, and it could really replace up to 400 liters per hour of diesel energy when it's in that electric trolley mode. And so this is a tremendous opportunity. And just as an example, a single BWXT advanced nuclear reactor has an output of about 15 megawatts, and so it could support 4 to 5 trucks at a time on that trolley system and help reduce that diesel consumption, helping reduce your energy footprint in diesel and fossil, and reduce, therefore, your carbon and greenhouse gas emissions. Femto's mission is to be the connector. We are an energy integrating company, and our idea is that we would bring together the customer and the vendors in an end-to-end solution that helps find the clean energy solutions that the customer needs. We use the nuclear batteries as our primary vehicle for that. And we think that through our chairman and founders, myself included, we have connections throughout the industry. As you saw from those pictures, none of us are really young. We've been around for a while. And so we have the connections in the industry to bring together all the companies that would be needed to support these technologies. So what does a battery look like? Well, this is an artist rendering that was done by Norman Foster's team. To give you an idea of the scale of it, you can see the person standing here. And the size of these is such that this two-piece unit here, which includes the reactor core and a power systems unit, could fit in 2 shipping containers. So you bring it to a site, you'd be able to establish it very quickly, do the connections, and bring it up. And so don't think of these in terms of what you may think of for nuclear, which are the big cooling towers and the reactor systems that take decades to build sometimes and cost billions of dollars. These are in the millions of dollars, and these are things that can be deployed in less than a year once the technology is available. There are many of them that are out there being developed, and they all have the same characteristics, which is that they're extremely safe because they're using the newest kinds of accident-tolerant fuels that have been developed over the last 30 years worldwide. They're stable in the pricing once they get to next nth-of-a-kind costs. And importantly, for the kind of use cases we're looking at, they're transportable and redeployable. They take up a very small site footprint. So the same scale size that you would have to have a massive wind farm, these can fit literally one of in the stage that I'm standing on here. They have net zero, and they could be providing heat and electricity. As I say, there are many being developed by big companies like Westinghouse and BWXT, who builds all the reactors for the US Navy program. And these will be available soon. The BWXT reactor is actually being developed as part of an Army program for the United States military, and it will be demonstrated in the next 2 years at the Idaho National Laboratory in the US, and they believe that their commercial unit will be available by 2028. What are we ready to support? Well, obviously we're here because we're really interested, that we think that there's a tremendous opportunity in mining and electrification of mining, but you can see other places, and one of the places that we've had a significant amount of interest is in offshore oil and gas. Right now, to power their rigs, they actually burn their product, right? They take the energy that comes from that and they're burning it to provide the electricity and power that they need to operate those, and so we're looking at how you would electrify those with a reactor. But you could also imagine data centers that need a stable source of power and want to stay off the grid so they don't have to worry about grid reliability. And certainly we see plenty of opportunities. I was very excited at Centinela seeing the different opportunities there could be to use these technologies in mining. Our toolkit is basically world-class expertise. We have some of the leading experts on our founding team. We believe that we have the connections that we've already established with some of the vendors that will allow us to help find the right solution in the vendor market and the supply market to solve the low-carbon solutions that are needed for these, for mining or for data centers or elsewhere. We can start from end to end. So we do design, analysis, regulatory analysis. I will stop there for a second and say the most challenging thing most times for countries that have not done commercial nuclear is the regulatory space and the public perception space. We have expertise in those areas. We would help move those solutions down the field to make sure that they're ready and those issues are addressed up front, because the regulatory issues are probably one of the most challenging for the deployment of these technologies if it's not been in a country before. And then manage it all the way through the delivery of the power and decommissioning of the site and removal. And in the end, when we're done with that battery, it moves away, it goes back to the factory. It's the waste and everything that goes with it is not an issue for the customer. Our journey starts with the regulatory framework and building project developments, as I indicate. Once that's done, then, as you can see here in the mid part of this decade, we would work into the regulatory approvals and development of the energy solution, and then finally delivery of the reactor and power source to the sites. So by the end of the decade, hopefully operating a power source that's clean and reliable, and most importantly, sustainable and flexible. So when they're done and they've got their core life expended, you just bring a new battery in and you move on. So I look forward to answering any questions you might have out in the lobby here. I appreciate the opportunity to present it to you all, and thank you again to Antofagasta and to MIT.